Hello everyone. In this session, let's understand member initialization list. So what is member initialization list? So I have already written a class called person. Okay. And so here I have a constructor, which is a parameterized constructor, and I have commented out default constructor. Okay. So let's understand what is member initialization list and what are its advantages and when we have to use member initialization list. Okay. So here we have a person class and I have written a parameterized constructor. So I have initialized person object with 20 as age and Phillips as the name. Okay. So let's first execute this and see the output. Okay. So it is calling parameterized constructor and with the value 20 and Phillips. Okay. Now, so this is one way of constructing a object. So inside the one way of initializing the data members inside the body of the constructor, there is another way of initializing object. So underscore age, this is the name of the member, data member, and I'm passing age to this data member, and another data member is name. I'm passing argument name to this. So let's comment this out. Okay. So this is another way of initializing the data members in the constructor. So here also we expect same output. Okay. So what is happening? So this way of initializing the constructor is called initialization at member initialization list. Okay. So then you must be thinking, what is the difference? So here also we can initialize the data members and here also we can initialize the data members. So there are certain advantages and there are certain cases where we have to use initializer list. So we cannot initialize the data members in the body. We have to initialize in the member initialization list only. So what are those cases and what are the advantages of initializing here? Let's discuss one by one. Okay. So first, let's discuss what are the advantages of what is the use case why we need to initialize like this. Okay, let's say you have a data member age which is a reference data member. Let's say this is a reference. So what to understand by reference? So reference means usually normally how we write reference. So usually let's say you have integer ref, let's say you have integer equals 10, and this reference, if you want to refer, the syntax is like this. Okay, this is how you write, right? Let's compile this. Okay, so this is compiling. What do you mean by this reference? So this is nothing but alias to this I. Okay, so this is pointing to what this reference is pointing to the address of I. Okay, that's what it means. Can you write reference like this? Is it possible? First declare a reference, then assign value to it. Is it possible? No, it is not possible. Okay, we can try this out. It says ref declared as reference but not initialized. It means that when you declare a reference, it has to be initialized then and there itself. It violates if we don't initialize the reference. Reference means what? It is referring to something. It is not on its own. It has to refer to something. So here the reference is missing. So we have to initialize it when we declare. Okay. And another thing is we cannot initialize to any literals. Okay, this is also not possible because 10 is not addressable. Okay, reference will refer to a variable which is addressable. So 10 is a literal, it is not addressable, right? So like I, you cannot use 10 like the way you use I. So this is not possible. So this will give an error. So cannot bind non-constant L value reference of type int ampersand to a R value of type int. Okay. So this 10 is an R value. R value means it has the value which can come only after the equals. That is called R value. This is not an L value. So you can refer only to an L value. Okay. Just remember this. Now, so with this background, let's see if it compiles. Okay, with this background, let's say in your class data member, you want to have a reference. So how you initialize it? Okay, let's say you will initialize it like this. Okay, so let's see what happens. You see here uninitialized reference in int ampersand. Okay, this is because you have declared age as a reference variable, and in the constructor when you are constructing an object, okay, age, it will try to create age by the time it enters this constructor. Okay, so when you are constructing a person object, when it enters the constructor body, it will try to create all the data members. Okay, so it will try to allocate memory for all the data members, then you are assigning a value to it. But this violates the rule of reference. So reference has to be initialized when it is created. So here after creating the age, we are trying to assign a value. This is not possible. Okay, this is not possible. This violates the rule of reference. So how we can initialize this? One way to initialize this is with the initialization member list. Okay, so by initializing like this will compile. Okay, now this is one use case how you initialize the data members when you have a reference variables. Another use case, let's say you have a const. So like reference, what do you mean by constant? Constant means you should be able to, or if you have a constant variable, it has to be initialized at the time of declaration itself. So again same concept applies here. So if you want to initialize inside the body of the constructor, which is by then this string name is already trying to construct, so inside the body, so this is already construction of this name is already happening. So when it is trying to construct, the name, its compiler sees const keyword, and it also sees that it is not initialized. So what do you mean by constant? So if the variable is declared as constant, it cannot be changed again. So it has to be initialized then and there itself. Okay. Let's see. Let's try to comply. So passing const string as this argument discards qualifier. Okay, underscore name equals to name. So first we are trying to construct name, then we are trying to assign a value. This is not possible with a constant. So only way to initialize this is member initialization list. Okay, so it compiles. This is another use case where you need to use member initialization list only. Next, let's say if you are initializing data members inside the body of the constructor, let's say you don't have any references of const variables, still it is a good practice to initialize data members in the member initialization list only. Why not this? Because this has some performance overhead. So what is that performance overhead? Let's say when you create a object of person, so 20 and Phillips is being copied here, age and name. Okay, and from this age and name, the assignment operator of int and string is being called, because assignment copy. So from here to here it is again copying. Okay, so two times copy is happening, one here to here and from here to here. So this is a performance overhead. So what happens if we declare it like this? It will avoid the construction of an object. So it will not call construction of an object. So by entering into the while entering into the body, age and name is already created. Then you have assigning in this case. But when you do it like this, the age is not yet created. Okay, it will directly created via this argument age. So directly assign this value. Before entering into the constructor, this will be called. So it will just call the copy constructor. It will not call the default constructor of the constructor of int of string. So it will avoid constructor of those two. So let's say this is a very important interview question. Let's try to appreciate this. Let's try to visualize how it will call those constructor. So for that, let's write a simple another class. Okay, class address. Okay, let's say address has a data member called string underscore street and int underscore pin code. So address can have many other data, but let's say for example I'll use only these two. Okay, so let's write constructor for this address. Let's write default constructor cout address default constructor. Okay, let's initialize this street equals Kaveri street underscore pin code equals 560037. Okay, this is default constructor. Now, in order to see the copy constructor and assignment operators are being called, let's write copy constructor and assignment operator as well. So address const address ampersand obj. So this is a copy constructor. So let's print it out. Address copy constructor. Okay, so let's assign values. Obj dot underscore street, then underscore pin code equal to obj dot underscore pin code. Okay, this is a copy constructor. Let's also write assignment operator. Address ampersand operator equals const address ampersand obj. So this is also be same. Okay, address assignment operator. Okay, so let's return this object. Okay, so I have written default constructor, copy constructor, and the assignment operator. Now let's declare the object of address inside the person. So person have an address. So let's write like this. Now let's try to initialize address. Address. So what I am being, remove this member initialization list and will try to initialize inside the body of the constructor and see what happens. Okay, now let's see what all constructors will be called. Okay, so we're initializing the object. I need to pass one more argument, which is address. So let's pass address. Okay, so this is construction of the object in place. So when you write it like this, it will directly construct the object in the parameter. Okay, this is compilation successful. You see here, address default constructor. Let's comment this out for time being, just to see the clear output. Okay, address default constructor, address assignment operator. What is happening in the background? So first constructor is called when you call this or when you construct this object. Okay, basically when you call this person object, this address is constructed at the in the parameter list. Okay, that's why first default constructor is called. Now when it enters this body of the constructors, body of the person constructor, so it will, by that time it will create this address object. Okay, so when it creates this create this address object, the default constructor of the address is called again, and then when it enters inside the body, so this address what is constructed here will be assigned with this value. So now what is called assignment operator is called, address assignment operator is called. So totally there are three constructors are being called in this case. Okay, now let's see what happens when we do it in the member initialization list. Okay, what is the third argument? Third argument is address. Let's see what happens. Okay, surprisingly, they have only true constructors. Okay, one is address default constructor, another one is address copy constructor. There is no assignment copy constructor is called, or there is no assignment operator is called. Okay, and default constructor is also called only once. So let's see what is happening. So the first default constructor is called when we create the object here, address. Okay, now address copy constructor is called when? Address copy constructor is called when you are trying to construct or create address object. At that point of a time only, this already created address object is being copied here. So this is reason for invoking the copy constructor. So that's why address copy constructor is called. So this is happening in the while construction of this address object itself. So this address copy constructor is called. So by the time it enters the body of the constructor, this address constructor is created with the help of this address. So it will avoid another assignment operator copy. Okay, so this is the advantage, right? So this is a clear advantage. So in this case, if you initialize the data members inside the body of the constructor, 3 constructors are called, but here only 2 constructors are called. So this is a significant improvement in the performance. So in this is a very small example. An address is having only 2 data members. Let's imagine in your project where you have a heavy data members. Okay, that point of a time, you are avoiding one call to the constructor. So this is a huge difference in the larger projects. Okay, so this is another use case why you need to initialize data in the initialization member list. Okay, let's write it down. What are the use cases and advantage? First one is you have to use member initialization list when you have reference variables inside the class. Okay, only way to construct the object is with the member initialization list. Second thing is when you have const variables inside the class. Other advantage is it will improve performance while creating objects by avoiding additional call to the constructor. Okay, these are the 3 use cases. There is another use case, 4th use case. Let's understand the 4th use case. Okay, now I have a person class. Okay, and let's create another class called employee. Okay, this is employee class, and in this employee class let's inherit this person class. Okay, so this is inheritance. Employee is also a person, so this is a user relationship. Okay, when there is a user relationship you can have inheritance. Now what else employee can have apart from age, name and address? employee can also have employee code, right? So let's say you can have many other things as an employee, but just for this example I just take employee code. And let's write employee constructor. Okay, so this is a default constructor, uh, underscore employee code equal to 1000. Now let's comment this out. Let's say I want to create employee object now. So this is a hierarchy. Employee is divided from person class. Okay, and I want to create a object of employee. Okay, how I can create an object of employee? Employee emp equals to employee. So I have a default constructor in the employee. I can create an object like this, right? Now what will happen? Any guesses? Maybe pause for a second and think about it. Okay, see, there is an error. So what is the error? Let's see. So no matching function for call to person. So you are creating object of employee. Here it comes, but employee is derived from the person class. So it will go to person class. It will try to construct the person class first before it construct the employee object. Okay, when it tries to create a person object, it comes and sees that okay, there is no default constructor. Okay, and it sees that there is a parameterized constructor which is written. Now compiler will not generate default constructor. Okay, so it means that person class does not have any default constructor itself. So when it does not have default constructor, the person class can be constructed only through this constructor, which is a parameterized constructor. So in order to construct the object with the parameterized constructor, so person has to be called with these three parameters. But when I'm creating an object, I'm just calling employee, and I'm not calling with any parameters. So when I don't have any parameters, so automatically this will, while construction of this employee, it will try to call default constructor of this person, which is not present. So that's why it is saying that no matching function for call to person. How we can eliminate this error? One way to eliminate this error is you can write default constructor. Okay, this is very important. This can be asked in the interview. Okay, so yeah, this is just a warning because employee code is having conversion from int to char. Employee code. Okay, since I'm not initializing the 2350 employee code string, I'm assigning okay, integer to it. Okay, okay, okay. Now employee object is constructed. Now let's say you don't have a default constructor. Let's go back to the previous case. Now how you can construct the object? Okay, so in order to construct this object, you need to pass these three parameters to the person class. So one way to do this is, or only way to do this is, with the initialization member list. Here you can pass to this person, okay, age as 20, name as Maxwell, and you can create address object. So you have to use member initialization list. Okay, you cannot do it inside the body of the constructor. You have to use member initialization list. See, this is object is constructed. Earlier it was giving error saying that person object, so person, there is no matching function call for person. Now I'm explicitly calling the person constructor with all these three parameters. So it will call this uh, parameterized constructor and construct the object of a person before employee object is created. So by the time it enters the body of this employee constructor, this person object has to be created. So this is created with the help of this member initialization list. So if you remove this, it will not work. Okay, let's say if you try to construct this object inside the body, this will not work. This will not work because this will not work because by the time it enters the body of the constructor of employee, person object has to be created. That's the rule. Okay, so before derived class is initialized, its base class has to be initialized. That's the rule. So this is one way. What is the other way? Other way is also member initialization list, but you can have one another constructor with the parameters. Okay, here we can have int age, string name, and address. Okay, now call this employee with age as 30, name as Ram, and then address object. Will this work? Can you tell me whether this will work? Let's see. This will not work yet because even though you passed argument here, this argument is for this employee class, and before construction of the employee, again we'll try to construct person. Here there is no default constructor. Okay, there is no default constructor. Only way to construct a person is with this parameterized constructor. So we are not calling explicitly the parameterized constructor. Always remember, if your base class has only the parameterized constructor, it does not have a default constructor. Only way to construct is in your derived class constructor, you have to call that parameterized base class constructor. Well, that's the only way, and that's a rule that before construction of the derived class, its base class has to be constructed. So how we can do this? We can do it like this. We can call person and we can pass these arguments. Whatever is passed to the employee: age, name, and address. Okay, we're just calling parameterized constructor of person class before employee class is created. Okay, no matching function for call to person. Okay, I think it's because of this. Let's remove. So even though you are calling the parameterized constructor of the employee, still it is giving the compilation error for this constructor. So well, if you are allowing employee to be created with this default constructor, it has to have member initialization list for person class. Either that or you need to uncomment this. Okay, so I hope this concept is clear. So always remember that before construction of your device class, your base class has to be constructed. In order to create your base class, if you have a default constructor in your base class, that is okay. This will work. So if you do this, this will work. But if your base class does not have default constructor, then you have to explicitly call the base class parameterized constructor. Okay, this will work. So let's say now you don't have default constructor in your base class. So how to make this work? Only way is you have member initialization list in the employee constructor. So you can provide 20 max address. Without this it will not work. So just to show you, without this will not compile, because even though right now you are calling with this constructor, but you are still giving a provision to call this constructor by doing employee emp2. Okay, so this will still call this constructor, so that time it will fail. But if you initialize in the member initialization list the person class, then this will work. Okay, so these are the use cases where you need to use member initialization list. So what is the fourth use case? When you have derived class and its base class doesn't have default constructor, then in order to construct base class first, you need to use member initialization list. So this is the only way. So these are the 4 use cases and advantages of member initialization list. So remember, always it's a best practice to initialize your class in the member initialization list. Okay, so that's all with the member initialization list. Thank you. See you in the next session.